9.5 is about geometric series. Just like we had an arithmetic series yesterday, which followed in turn with an arithmetic sequence, you have a geometric series which follows with the geometric sequence. So you want to find what's the sum of the finite geometric series. By finite, they mean it stops. There's an end term, okay, or a last term. You're going to use this formula right here, S sub n equals a1 times 1 minus r to the n over 1 minus r. Now, a couple things you need. First of all, you need a sub 1. That's pretty easy. The first term is 3. You need r, which again is still pretty easy. 6 divided by 3 or 12 divided by 6. My r is 2. The only thing that you're going to have to work a little bit for is the number of terms, which is n. So to solve for n, I'm going to take my last term, which is 3,072, and set it equal to, if you remember, our geometric sequence was a1 times r to the n minus 1 term. And I'm going to solve for n. So let's divide by 3. I get 2 to the n minus 1 power equals 3,072 divided by 3 gives me 1,024. And now it becomes kind of a guessing game here. You can use logs. I actually like that. If you take the log of both sides, bring the n minus 1 down, divide by log, you can find it pretty simply. Or you just keep guessing. 2 to the 7th equals what? 2 to the 8th equals what? 2 to the 9th equals what? Well, through calculator work, you'll end up with 2 to the 10th equals 1,024. So I'm going to take the n minus 1 and set it equal to 10. That will give me what my total number of terms is. So n equals 11. So once I have these, I'm just plugging it in now. Let's find the sum of this series. So the sum of the first 11 terms equals your first term, which is 3, times 1 minus r, which is 2 to the 11th, over 1 minus 2. Plug it all in your calculator. You end up with 6,141. The next concept we're going to deal with is what they call an infinite geometric series. The first one was finite, which means there was an end to it. Infinite means there's no end. So an infinite geometric series, you use this formula. Okay? How do you know? Well, there's two ways that this infinite geometric series could be. It could either converge or it can diverge. If it converges, that means that it gets smaller and smaller and smaller and smaller. Our r is less than 1. If it diverges, it means it keeps getting bigger. Your r is greater than 1. Converging has a sum. Diverging obviously will never end. It just keeps getting bigger to infinity. Okay, so let's look at the first term. In the first series, 1 to half. What's my common ratio? Well, r is going to be 1/2 divided by 1. R is going to be 1/2. Well, 1/2 is less than 1. So I'm going to use this formula to solve. So my sum is going to be in the first term divided by 1 minus 1/2. That gives me 2. So the sum of this whole sequence that never ends is going to be 2. Okay, what about part B? Well, let's look. What's my r? My r in this case is negative 5/4. The negative doesn't matter. You want to look at the absolute value. 5/4 is bigger than 1, so this diverges. So there's no sum when we find that this converges. So I forgot to write that. You go from there.